Hello children, today I am doing indices and exponents for the 8th and the 9th class. Okay. Now, in this chapter you have done, we'll be doing how it is applied only for two operations, that is multiplication and division. Now when you are doing times table, 4 times table, 2 times table, like when they say 4 into 5, 4 5s are 20, we are doing continued addition, repetitive addition. 4 5s are 20 means 4 plus 4 plus 4 plus 4 plus 4, 4 added 5 times is 20, or 5 added 4 times is 20. So 5 is being added to itself 4 times. Similarly, when you have 5 being multiplied with itself 4 times, 5 into 5 into 5 into 5, we write 5 to the power of 4, right? So repetitive multiplication and repetitive multiplication or division come under this chapter called indices or exponents, right? So here you have like a plus a plus a plus a is 4a. The 4 comes in front of a means 4 times a. But the same thing when I write into, the sign is only multiplication and the number is only a or the same number. So a into a into a into a is a to the power of 4. 4 becomes the index, the power which is right on top of the number, and a is called the base, right? Like when you have 3 times x cube, it's 3 into x into x into x. The x is being raised to the power of 3, not 3. It is 3 raised to the power of 1 into x cube. The second one, the other one is 3x to the power of 3. 3x. The 3x is in the bracket. So it is 3x into 3x into 3x into 3x, which becomes 27x cube. So 3x whole cube is 3x into 3x into 3x. Minus x to the power of 4 is minus x into x into x into x, right? So, but in the other one, it is minus x in brackets to the power of 4. So, the minus is also written 4 times along with the multiplication sign. Minus x into minus x into minus x into minus x, which is plus x to the power of 4. Right? Here, if it is minus x cube written this way or minus x in bracket cube, odd powers written, the incorrect and the correct answer will happen to be the same. So minus x cube also becomes minus x into x into x, x cube, and minus x whole cube minus multiplied 3 times by itself is minus. Okay, so there the coincidence, the answer becomes right. So I gave you an example with the power as an even number. So looking at this, now we'll come to the laws of indices. Okay, what are the laws of indices, which is very, very important. As I'm writing, please write down the laws of indices. Okay. So let's see the first law. What happens? So be very careful when I'm writing the laws of indices. Number 1, a to the power of m into a to the power of n is a to the power of m plus n. Meaning a same number, both written in exponential form, where m and n are numbers. They can be whole numbers, they can be negative numbers, they can be fractions. So m and n stand for all real numbers. It can be negative whole number, integer, it can be a whole number, it can be natural number, it can be a fraction. Whatever it is, we add it in multiplication. Second law is, for example, you have x cube into x4. Answer is x7, not x12. Okay? We add the powers, and this x written once, not written 2x. Or it's not written x square. It is x, the number which is repeating, and just add the powers. Example. Second one is a to the power of m divided by a to the power of n, which also can be written as a to the power of m this way also. So this means a to the power of m minus n. The confusion lies that it is m minus n or n minus n. Both answers are different. 4 minus 3 is 1. 3 minus 4 is minus 1. So therefore, it is am divided by an. The divisor's power will become negative, and the first number which will stand in the numerator, that will be positive. A to the power of m minus n. Okay. This goes up, and we'll come to that. When does it become negative? So in division, we subtract the powers. Third one, a to the power of m raised to the power of n is a to the power of m into n. A to the power of m raised to the power of n is a to the power of mn. We multiply. Okay. When you have a to the power of 3 to the power of 5, it is not a to the power of 8. It is a to the power of 15. 3 5s are 15. What is the meaning of a cube to the power of 5? It means a cube into a cube into a cube into a cube into a cube. And just now we did first law, all the powers are added. So a cube has been multiplied by itself 5 times. So therefore 3 plus 3 plus 3 plus 3 plus 3 is a to the power of 15. 3 added 5 times is 15. That is why it is a to the power of 15. This is the example. Third law. Fourth law. Okay. Fourth law is that when you have, so I keep on writing as many as the formulas, as many as laws, because in the book they just give the multiplication, division and the power raised to a power, right? So first thing, if I have, for example, fourth one, if I have a into b to the power of n, it is an and bn. So here you have to be very careful. If it is 2 numbers or 3 numbers multiplied with each other and all of them are raised to the same power n, how do you know that? There is a bracket. All are kept within the bracket, right? So then it is, you can distribute the power an into bn. Children, the vice versa is also same. That means an into bn you can write as ab to the power of n. If you have, for example, 2 into 3 to the power of 4, it means 2 to the power of 4 into 3 to the power of 4. Okay, that is 81 into 16, right? Or 6 to the power of 4 is same as 16 into 3 to the power of 4 is 81. Okay. Also, let us say another one. If I have x5, y5, I can write this as xy to the power of 5. Right? Both ways you have to know a formula. If it is x plus y whole square is x square plus 2xy plus y square. Remember, x square plus 2xy plus y square or x square plus y square plus 2xy will also be x plus y whole square. Okay, so that is fourth one. Fifth one, let us go to the division rule. Okay, fifth one. If I have a upon b raised to the same power, I can make it a to the power of n divided by b to the power of n. If you have, for example, you have suppose 2 by 5 raised to the power of 3, it means 2 cube by 5 cube. So answer will be 2 into 2 into 2, 8, 5 into 5 into 5 is 125, 8 by 125. Now the vice versa. Let's take another example. If you have, for example, 5 to the power of 2 and 7 to the power of 2, right? 25 by 49 is also the answer. And this also 5 by 7, the whole thing to the power of 2. So if I give you 5 by 7 to the power of 2, your answer will be 5 square by 7 square, which is 49. Okay. So both ways, remember, this way and this way. Please go both ways, right? Not one way. Okay. Next one. That is division and multiplication. Then let us come to negative powers. When does a power become negative? Before that, we should know 1, 2, 3, 4, 5. So sixth one, if I have any number to the power of 0 is 1. Okay, any number, whether it's a known number raised to the power of 0, it is 1. If I have 243 raised to the power of 0, it is 1. Now why? I am going to explain to you why. Many people do not know why. Because one is that we know that indices is only for multiplication and division. And 1 is the result of adding two same numbers, right? Whether you take n by n, we cut it, we get 1. Okay? Whether we take 71 by 71, we cut it 1 by 1, we don't write, we write as 1. Right? Whether we write say x to the power of say 5 and x to the power of 5, then also it is 1 because x into x into x into x into x and x into x, all the x's get cut, then also is 1. So let us go to the law of indices. What does the law of indices says in division? We subtract the powers. Okay, 5 minus 5, the numerator's power minus the denominator's power if you are writing it in the numerator. Okay, so answer is x to the power 0 and that is 1 because just now you saw all the x's, each x gets cancelled. There are as many x's in the numerator as many x's in the denominator. If you follow the law of indices, division, we subtract the powers. That is why x to the power of 0 is 1. Okay. Now coming to negative powers. Now if I have a to the power of minus n, it is 1 by a to the power of n. So a to the power of minus n is 1 by a to the power of n. Right? So therefore, because a to the power minus n, I can write a to the power 0 minus n. And when do we do division? When do we subtract powers? In division, we subtract powers. Yes. So I can write minus n means 0 minus n. So when do we subtract the powers in division? The first one we have to write in the numerator, a to the power n. So and a to the power 0 is 1. So 1 by a to the power of n. Okay. So negative, you just have to make it reciprocal. So reciprocal of a number is that number which when multiplied by the number, the result is always 1. So whenever I say what is reciprocal of 2 by 3, you know what my children say? Miss, ulta pulta. Miss, bring it upside down, ulta pulta, up and down. That is not the answer. That is for you to know that 2 by 3 is reciprocal. I make it upside down, inverse, that will become 3 by 2. But actually, reciprocal's definition, if I say what is reciprocal of x, okay, it is that number when multiplied with x will give you 1. Okay, so x into y is 1, then reciprocal of x is 1 by y and reciprocal of y is 1 by x, right? If the product of two numbers is 1, then those two numbers are reciprocal of each other, right? So you will see that 2 by 3 into 3 by 2 is always 1. So you say ulta, pulta, upside down and all that, right? So now here that is why the negative. The other thing, 6 and 7, go on one by one, we'll be going one by one. The other one is say a to the power of a by b to the power of minus n. So you want to make it positive, I told you, always think positive, write positive. So here we write b by a to the power of, yes, n, because just now I told you, this is same as a to the power minus n, b to the power minus n. And just now I said, if I make it reciprocal, it will become positive. And what is reciprocal of 1 by b to the minus b to the power of n? And what is b by a to the power of n? You can put bracket. So that's how it is. If you have, example, if you have 2 and by 3 to the power minus 3, how will you do 2 to the power minus 3? You will say 2 multiplied by minus 3 times. How can it be? Okay, it is not 2 multiplied by minus 3 times. Number of times cannot be negative. So it's just like 1 by 2 cube. I want to write it in the numerator. I make it 2 to the power of minus 3. And I showed you also why 8 to the power of minus n is 1 by 8 to the power of n. Okay, so this is make it reciprocal. And if it makes reciprocal, sign will change. It will become positive 3. So now you know it is 3 cube into 2 divided by 2 cube. So 27 by 8. Okay, which if you make this, you know, sign will change. If you interchange the denominator to numerator, numerator to denominator, making reciprocal. So sign of that changes. So this is actually the meaningful thing, and this is the one which you write. It doesn't mean how can I multiply to negative 3 times, right? So that is reciprocals of the numbers. Now if you have, for example, so we have done, suppose you have like say 2 by 4 by 9 to the power of minus half, right? We'll be doing fractions also. So that will be 9 by 4 to the power of half. How to solve this we'll do as I'm explaining them. Okay, so we change the sign of the power. One more thing, children, be very careful when I say x y cube. Okay, x y cube. What's the meaning of this? X into y. See what is the power on that? What is the power on each term, each variable or each number? It is x1. Not written means 1, not 0, because x power 0 becomes 1. Right? So you have x1, y3. So x1s and y3 times. If I want to write xy to the power of 3, this is same as x cube, y cube. One of the laws I did, ab to the power of n, ab in bracket to the power of n is an into bn. So here you have x. So that means this is x into x into x, and then continue y into y. So instead of writing such a long train of numbers, we write it in a short way called exponential form. Okay. So now this is on multiplication and division. So if you have like example, now we are coming to representation of indices. Okay, representation of indices. So if you have x cube, y5, okay, 2 to the power of 10, whole numbers or integers, we can only write like this. But what happens when the power is a fraction? So there's only one way of writing when the power is a whole number or integer. Integer means it can be negative also. So how else can you write x to the power minus 5? 1 by x to the power of 5. Okay. How do you write 1 by y to the power of minus 3? You make it reciprocal, right? 1 means y to the power of 0, right? So you have y to, I'm just saying answer to y to the power of 3. Why? Because y to the power of 0 by y to the power of minus 3. Yes, which is, so y to the power of minus 1 by y to the power minus 3, I wrote y to the power of 3. I'll tell you why also. Because it is y to the power of 0, this is y to the power, and division we subtract the powers, 0 minus of minus 3. Yes, that is why it becomes, what is minus into minus? Plus. That is why it becomes positive. Okay, so all these are only the, but what happens if the power is a fraction? Then there are two ways of writing the exponential form, right? I told you 32, and if you write it as 2 to the power 5, which is the exponential form? This is the exponential form. This is exponential form. Okay, when you write, because 32 is a repetitive multiplication of 2 multiplied 5 times with itself. So that's why this is 32 can be written as 2 to the power of 5. Can I write 11 in exponential form? No. Okay, we can write as some base to some fractional powers. Okay, you can write 121 to the power of half. That we'll be doing. So I'll be doing next, right? So like if you have, for example, 64, I write 4 cube. This is exponential form. If you have a base and an index, that form is called exponential form, right? This is 4 is the base, 3 is the power, which is also the index. Okay. Now what happens if the index is a fraction? If the index is a fraction, for example, if you have a to the power of 1 by m, or you have b to the power of m by n, like you have x to the power of half, y to the power of 3 by 4. So here you can see the index, the powers are fractions. So therefore you have two ways of writing it. This is the exponential form. What is this form called? This format is called exponential form. There is a base and there is a power. This is exponential form. The base is x here, power is half. The base is y here, power is minus 3 by 4. You can give another example, minus 2 by 7. So base is a and the index is minus 2 by 7. So if the power is fraction, positive or negative, there are two ways of writing it. One is exponential form. This is called exponential form. So what is the second form of writing? That's called radical form. Okay. That is called radical form. So radical form for writing x to the power of 1 by m or x to the power of a by b and so on, where a and b are numbers, integers, right? So if you have like x to the power of 1 by m, we write as m inside this little curvature and x and the numerator here. So this is called, if the numerator, if x is raised to the power of 1, this is 1, the numerator is 1 and the denominator is any number, right? So that is, how do you write this? Mth, this is radical form. This is called mth root of x. Mth root of x, right? Suppose you have like 2 to the power of half. We write 2 here, numerator here, we don't write 2. 2 is understood. We don't write 2. The moment we don't write 2 means the denominator of the power is always 2. And this is called square root of 2. Square root of 2. The other powers you write. If you have 3 to the power of 1/3, then we write the 3. 3 power here and 3 here. That 3, the denominator of the power or the index is written in the small curvature and the numerator is written here. And whenever the numerator is 1, we say nth root of that or third root of 3. Third root of 3. So which is also called cube root. Okay. So this is cube root of 3. Let us see some more examples. Now you will wonder what happens if there's not 1 in the numerator, there's some other number in the numerator. A to the power of 2 by 3. No problem. What did I say? Radical form. This is called exponential form. This is exponential form. Which one? This one is exponential form. Exponential form. Yes, that is base is A and index is 2 by 3. And now we come to radical form. Right? The radical form you will see. Okay? Radical form is A. This symbol we use like a tick. Okay? A small v and then like a division sign, use division sign. And here denominator is 3, small 1. You should not write like this. This is wrong. This means 3 times square root of A. Okay? It should be inside that curvature, little curvature. And the numerator is here. How do you read this? Cube root of a square. This is cube root. So cube root of a square. Right? Cube root of a square. If I have another number, say I have 16 to the power of. Okay? Say another number I have, radical form. So I have, suppose, 16 to the power of 3 by 4. Right? So we write, this is exponential form, and now radical form, put a, like a right sign, b, and then a division sign, put 4 here, the denominator, and 16 cube, right? So, of course, there's a shorter way of doing it, but how to write? From exponential to radical, radical to exponential form. Okay, so this is read as fourth root of 16 cube of 16, cube of number 16, not cube root. Cube root becomes 16 to the power of 1/3. When you put the word root, it becomes the denominator of the power. Okay, so knowing all this, that is radical form. So you should also know, suppose I say this 2x3, right? I did not put anything here. So you often seen it, you have used it even areas, area of square, L square is 16, as L is square root of 16. You use the word square root. Standard 5, 6 have done square roots. Okay, you must have used this symbol. There you never wrote 2 here. So this is 2 to the power of 1, x to the power of 3, the whole thing raised to the power of half. Because square root of means 2 is never written. Right? And the other rule, what it will learn? Power raised to power, we multiply. So 2 and 1 into 3 by 2 is half, and x into x to the power of 3 by 2. Right? But what happens if I write another example? I'll give many examples so that especially you are not confused with the fractional indices. Okay? Suppose I give 3 into x to third. Write this in radical form. 3 is a whole number. It does not have any fractions on top of it. So it will never come under the root sign, under that radical sign. So you will write 3 as it is. Only you will write x, the numerator with the inside, and cube root. Which number we don't write here? Square root, when the power is half. When the denominator is half, it's understood that if it's not written in number, that is square root. So this is radical form. Is it clear? So if I say like, let's say xy to the power of 5 by 6, right? So this is, both are raised to the power of 5 by 6. Bracket, just now we did a rule. AB to the power of n is an into bn. So this one, x to the power of 5 by 6 and y to the power of 5 by 6. Both are raised to the power of 5 by 6. In the previous sum, 3 was to the power of 1. Yes? So here you write this xy inside. There's a radical sign. It's not a 2. So I write the denominator, bracket numerator. With the bracket you have to put y. If there's no bracket, the child writes this x, y, 5. This is wrong because this means x power is 1 by 6 and 5 y 5 by 6. So this is not same. It is wrong. Is it clear? So therefore be very careful. So this is your first exercise to do exponential to radical, radical to exponential. In some books of these days, they do not use that, but they use the sign, but they do not have an exercise where you have exponential to radical, radical to x. You must have seen these signs, okay? So now one thing I didn't tell you, if the power is negative and you have to write in radical form, yes, you must be having that in mind, yes. So let us see, teacher has shown all positive fractions. What about negative fractions? Suppose I have like x power minus 2 by 5, okay? First change it to positive. Negative should be erased, should be converted to positive. So this is, you can write like this also. You can first write like this. The negative is not taken with the denominator. So you should never have negative written here. Remember that. So when I write minus 2 by 5, or teacher writes 2 by minus 5, or teacher writes minus 2 by 5. Children, all are same. All are same. Minus 2 divided by 5, the answer minus divided by plus is minus. Minus of the fraction. So whether I write minus before the fraction, whether I write minus in the numerator, whether I write minus in the denominator, because plus divided by minus is also minus, minus divided by plus is also minus. So all are the same. So in radical sign, don't tell, even if teacher gives you 2 by minus 5, don't write minus 5. In that curvature, the V, you never write negative denominator. Okay, negative does not mean minus 2 by minus 5. Okay, it is minus 2 by minus 5, 2 by 5. So therefore, we write the minus always with the numerator, and this should always be positive. Again, I told you we should avoid negative. So index generally is not given as negative index. So we write this 5, and we taught you this, yes? Did we do this? X power minus n is 1 by x to the power of n. So it is this. So how do we read this? Fifth root of 1 by x square. Fifth root of 1 by x square. Right? When I say 2 to the power of, or 8 to the power of minus 2 by 3. 8 to the power of minus 2 by 3. It means cube root of 8 over minus 2. More correct, it is cube root of 1 by 8 square. Means it's cube root of 1 by 64. That means this is 1 by 64 and cube root of that. That is written this way. Okay, that is the meaning of 8 minus 2/3. Hope you understood how to write. So when do we use this radical sign? Only when the power of a number is a fraction. Be it proper, be it improper, be it negative, be it positive. Okay, even if you have x 5 by 4, this is exponential form. X to the power 5 by 4, improper, so what? It is a fraction, exponential form, radical form, numerator this, denominator this. Okay, if it is x to the power minus 2 by 6, which can be written, you can reduce it, yes, you can reduce it. You can reduce that fraction. 2 by 6 is same as 1 by 3. 2 by 4 is same as half, square root. Yes, so which is written like this? Numerator, always take the negative with numerator, never inside this negative. Okay, so it is cube root of x power minus 1 is little incorrect to sound. So we say cube root of 1 by x because this is cube root of 1 by x. Right? So therefore, now you will have another one. Suppose write in radical sign. X to the power of 2 by 5 raised to the power of minus 1. Write in radical sign. So you know power raised to power we multiply. So minus 2 by 5. Now just, okay, we multiply. So plus 2 by 5 into minus 1 is 1. Now you know how to write this. Okay, you can write x power minus 2, 5 here, and then we write it positive. Never be negative. Never keep negative in life. Right? So this is it. You can directly do like this also. 1 by x power 2 by 5. So we are writing like this. Some children write like this. X power 2 raised to power 5. Like this. Okay. This is also correct. This is also correct. Both are correct. Okay. So now coming to, so we have done what is exponentials. Okay. And what is it made of? A base and a power. This is only used for multiplication and division. Right. So remember, beware. You know, I tell my children, beware of dogs, we say. So beware of certain things. When you have a plus or minus b to the power of 4, it is not a4 plus b4. It is not a4 minus b4. We cannot bring the power inside the bracket because this is not indices. This is not multiplication sign. The sign between a and b is plus and minus. So whatever rule is for this, which is a4, b4, it is not for this. What is the sign in between? Plus and minus. Okay? It is not. So often we see when I give children like 8 1/3 plus say 64 1/3 to the power of 3. You know, there's a eating sign, power raised to power. You get 1. So people write 8. They bring the 3 inside. This becomes 1/3 into 3, 1 and 64 to the power. Answer they give as 72. Wrong. Wrong. You cannot bring the power inside. See, check their sign. What is the sign between two numbers? Addition. Or if it's minus, what will be the sign? My exponential indices is not for addition and subtraction. It's only for two operations, multiplication and division. Correct? So, now you have fractions. Teacher is saying fractions. How do you solve? In variables fractions, you just add the fractions, right? But if you have, for example, evaluate, means you have to find the simplest answer. When I say 16 to the power of 3 by 2, okay, we can evaluate. Instead of finding square root of 16 cube, that's too long. You have to do division method of square root. So what is the short method? Change this to exponential form. Okay, you can make it 2 to the power of 4. You can make it 4 square. So let us make it 4 square. And 3, but this also should be in exponential form, not addition of two numbers or subtraction of two numbers. Then you cannot bring the power inside. So this also should be such that power raised to power we multiply. So this gets cancelled, answer is 4 cube, which is 64. Let us see the child was done 2 to the power of 4. 2 to the power of 4 is 16. 3 by 2. Cancel this. Because we are multiplying 4 and 3 by 2. So it becomes 2 to the power of 6 is same as 4 cube, children. Is same as 4 cube, right? Not, you don't have to see by multiplication. 4 cube is 64, 2 to the power of 6 is 2 into 2 into 2 into 2 is also 64. So you should by heart 2 cube is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, right? So 2 to the power of 6 is 32 into 64 and so on, right? So certain things you should know. Up to 3 to the power of 5 you should know 3 cube is 27, 3 to the power of 4 is 81 and 3 to the power of 5 is 243 and so on, 81 into 3. Right? 7 square is 49, 7 cube is 343. You should know some numbers up to cubes and fours. So it becomes easy to solve in exponential form. Now how do you know, without multiplying, how do you know that both are same? I'll write this as 2 square. 4 cube as 2 square. And power raised to power, we don't add. It is 2 square into 2 square into 2 square. 2 plus 2 plus 2. That's why multiply. It is 2 to the power of 6 without multiplying. Okay. If somebody says that prove that 729 is what power? So suppose you have 729, that is 9 cube. Prove that 729 is 9 cube and is also 3 to the power of 6. Prove. Of course, you can do like this and keep on dividing by 9, 81, 9 and 9, so 9 cube. Okay, 9 into 9 into 9 is 729. Now prove it is 3 to the power of 6. So 3 square is 9 and power raised to power we multiply. Therefore, it is 3 to the power of 6. Okay, children. So we are just continuing in my next video some examples on indices. Okay. Thank you.